Welcome to the deep dive on S3. As I said, my name is Lee Keir. I am a storage specialist solutions architect. And what that means is that I help customers to use S3 and other storage platforms within the AWS platform so that they can get the best performance, the best use out of S3 in particular. So let's get started. So customers have taught us to think about the cloud storage using 4 key elements. Multiple elements are usually required to make a cloud storage journey, but all 4 choices ensure the best choice for success. To be very clear, customers view AWS as the gold standard for cloud storage. Competitors struggle with the breadth of offerings and wind up using price as their only weapon. There is no comparable file system for the cloud. There are no comparable data transfer options. Look at all these data transfer options we have here, and there's no comparable hybrid cloud integration ecosystem. Customers have asked for file systems to work on a petabyte scale with consistent latencies. And the new Amazon EFS up in the top left corner is our new file system. It offers simple file interface for EC2 instances with scale and performance far beyond traditional on-premise or cloud-based offerings. And these can be accessed from multiple EC2 instances at the same time, which differentiates them from block storage, which we'll get to in just a moment. S3 and Glacier Object Storage is the ultimate repository that is durable and cost-effective at scale for developers writing cloud-native applications, as the data lake for big data analytics projects. This year, Gartner estimated that AWS is 1.6 times larger than all other cloud or object storage combined. And Elastic Block Storage provides the lowest latency in the portfolio with provisioned IOPS and general purpose SSD volumes for high IOPS and low latencies, and low cost throughput optimized storage volumes to lower the cost of using persistent block storage on EC2 instances. EBS supports a broad range of workloads from transactional databases, MySQL, SQL, Oracle, and NoSQL databases, MongoDB and Cassandra, to big data, Hadoop and Kafka, and for data warehousing. And organizations need a wide variety of means to move their data to the cloud. And we offer a wide variety of options there. So let's talk just briefly about those. We're not going to talk about them much in the rest of the presentation, but AWS Snowball, Snowball Edge, and Snowmobile provide a way for you to be delivered hardware to your site, which then you can load with data and send up to the cloud, making it very easy to send large amounts of data. For instance, the Snowball comes in sizes of 80 terabytes or 100 terabytes. The AWS Storage Gateway allows you to connect via NFS directly to your S3 bucket. AWS Direct Connect is a way to connect going outside of the internet system, which we're least lined, if you want to think of it that way. There are several third-party connectors. We will talk about transfer acceleration in just a few minutes, and Amazon Kinesis Firehose for streaming. So as you can see, there's a wide variety of ways to get your data into the cloud. So what to expect from this session? So we're going to talk about how to pick the right storage class for your use case, automate management tasks, best practices for optimizing S3 performance, and tools to help you manage your storage. There are also a lot of AWS storage partners available. If you have data on-premise, you probably have software from one of these industry leaders. Some of these can help you migrate your workloads into AWS so your applications can run on AWS or on a hybrid architecture model. They make it easier for you to migrate or scale your growth and leverage S3 and Glacier as cloud storage targets. So S3 has 3 storage classes available. For your most active data, we recommend that you use S3 Standard. It's designed for active data, particularly hot workloads, high performance, and designed for 4 nines of availability and 11 nines of durability. So what does that mean? That means that if you were to store 10,000 objects in S3, you would on average lose 1 object every 10 million years. So that's pretty darn good, much better than you can get in an on-premise environment. S3 standard starts at a price of 2.3 cents per gigabyte. And as your data ages, it tends to be accessed less. So standard infrequent access is designed for colder or less frequently accessed data. It offers the same performance of 11 nines of durability, but it has a slightly less availability, 3 nines of availability. It offers high throughput and low latency, just like S3 standard, and starts at 1.25 cents per gigabyte, 45% less in storage cost than standard. However, there is a 1 cent per gigabyte retrieval cost. So if you are retrieving your objects frequently, you will find they will be cheapest in standard, but if you are retrieving them less frequently, then you should consider moving them to standard infrequent access. And we'll go over how to make that decision later. As the data ages further, no one is actively interacting with the old data, and you need it, perhaps you need it for record keeping or for compliance purposes. Then Glacier is designed for that long-term archival storage. And it is priced at 0.4 of 1 cent per gigabyte, and it has 3 retrieval options. You can retrieve your ranging from minutes to hours to even days. So Glacier is not where you want to put data that you want to be able to access in milliseconds, but that you can wait a little bit to retrieve that. In addition to transitioning your data to SIA and its characteristic change, you can also leverage S3 standard for new data that fits the bill of infrequently accessed data. We do have several customers who use this for archival or for backups that they don't anticipate needing, but will want to be able to retrieve quickly should they need that. So storage classes are designed for a variety of different workloads, as we've talked about. S3 standard is primarily used for big data analysis, content distribution, and static website hosting. Two of the big customers we have for that are FINRA and Netflix. Netflix obviously uses AWS extensively. And with standard IA, it's primarily used for backup and archive, disaster recovery, file sync and share, which tends to age over time, and long retained data. Customers who utilize this storage class include Pinterest and Huddle. And finally, Glacier is used for, as I said, long-term archives, perhaps digital preservation, or even magnetic tape replacement. We have seen customers who have taken their tapes from Iron Mountain and moved them to Glacier. Again, Illumina and Sonida is our 2 customers there. So when should you move to SIA? Well, we found when we created this storage class that was a common question for customers. So we introduced S3 Analytics, our storage class analysis. It allows you to visualize the access patterns on your data over time, measure the object age when your data is infrequently accessed, deep dive into a bucket, deep dive either by bucket, by prefix, or by specific object tags. And tags are something that's fairly new, and I'll go into that as well in a few minutes. And you can easily create a lifecycle policy based on the analysis. It makes it very easy to figure out when you should move to SIA and when it will be beneficial to you. So here's a graph of what we would actually display to you. You can see at the bottom there's a graph that shows the age of your data, your storage, and your data retrieved, your total size of your data, and how much of it was retrieved. And at the very top, you see that it actually says, based on your storage over the past 115 days, we have observed that objects older than 90 days are infrequently accessed. So as I said, we usually find that data gets colder over time, and this will give you a visualization of that. Here's another shot that you would get that shows how your data is accessed. As you can see, the top level and the one on the very left, these are all frequently accessed. But as it gets over 90 days, then this changes. And we will recommend that after that period, you would want to have moved to SIA. Now, this data that we provide to you, you don't have to take our word for our recommendation. You can take that data that we will provide to you, use any of the tools that you normally use, whether that's Excel, Tableau, Redshift, TIBCO, any of these will be able to analyze this data for you. So how do you configure this? Well, if you look here, you may not recognize this page. This is actually the new S3 console. And there are some new tabs up at the top. You will see at the very top, we have the management. So this is a new tab for S3. So you click the management tab and then the analytics tab, and you can configure a new filter. In this case, we just chose data lake prod as our filter name. And in the second field, you can choose either, if you leave it blank, it will do the entire bucket, or you can do a prefix within the bucket, or even a specific tag. And then optionally, you can export that data, and that will be delivered to your S3 bucket. It will take about up to 2 days before the data starts to appear on the screen. And it will take up to 30 days before we actually give a recommendation. You would not want to move any data to SIA prior to 30 days, generally, so we don't make that recommendation. So that's picking the right storage class. Let's look at automating management tasks. To automate management tasks, we recommend use lifecycle policies to tier your data. So when we say you should move your data after 90 days, we can do that for you within the lifecycle policies. It allows for automatic tiering and cost controls, and you can transition between storage classes, or from standard to SIA or to Glacier based on age. And you can also expire objects. Perhaps you have objects that you know that after a certain amount of time, you don't need them at all, and we can automatically delete those for you. And actions can be combined. And we'll talk about that when we go through the example. You can set policies by bucket, tag, prefix, or again, tags, which again, I'll get into a little bit later. And you can set policies for versioned objects or for non-versioned objects. So here's an example of a lifecycle rules that's being created. This is a wizard within the console. And you start with your name. You can name it whatever you like. And then you look at the scope of this bottom section. In this particular example, we have a prefix 1, and a tag, department equal finance. And finally, someone was starting to do the tag classification. Although you'll notice that there's tag classification and up says prefix classification, so you could either do a prefix or a tag within that same area there. Then you go to what their transitions are. So this is transitioning from one storage class to another. In this example, we're doing the current version, and we are transitioning to standard IA after 90 days, and to Glacier after 365 days. So this is a fairly common configuration where as data ages, it goes to SIA, and then eventually it's not accessed very much at all, and we can move it to Glacier for archival. We're going out to expiration, so this is actually deleting your data. You can again configure either your current version or your previous version. I should mention that you can have that in this previous one, we could have done both at the same time, but both current version and previous version, but perhaps we had a different thing we wanted to do with our previous versions. In fact, generally, you would usually just expire a previous version and not do a transition for it. Okay? So in this example, we're doing a current version and a previous version, and we're going to expire the version object after 10 years and permanently delete after, again, 10 years from being a permanent version. So we're going to do the same action for both the current and the previous versions in this case. So let's talk a little bit about versioning. Versioning is great for protecting against unintended user deletes. The reason is you can actually recover your deleted objects and roll them back to a previous version. So this gives you a protection almost like a recycle bin. And we highly recommend that people turn on versioning, even if you're not reusing the same object names, so that just in case there's something happens, someone deletes your object, you can actually come back and retrieve them. In fact, here we are going to talk about the recycle bin. So you can actually not only talk about have the versioning with your to be able to bring back your objects, but you should also set about an automatic cleaning using lifecycle policies. S3 also offers S3 event notification. And what this allows you to do is you get a notification for any put, post, copy, multipart, upload, or delete. In other words, anytime you put a new object or you delete an object, it will trigger this event. You can filter this on prefixes or suffixes and trigger workflows with SNS, Amazon SNS, Amazon SQS, and Amazon Lambda. Notifications can be published to different targets. SNS topics for broadcasting events to a large number of clients, push emails or mobile alerts. SQS topics for processing S3 events asynchronously in a flexible manner. This is a good choice for triggering workflows that pull from a queue. And Lambda automatically executes code when an S3 event occurs without provisioning any servers or managing instances. Customers like Human Longevity use S3 event to trigger Lambda for their genome processing. And Turner uses S3 event to trigger Lambda for their content processing. So let's talk a little bit about the benefits and what's in it for you. Well, the first is simplicity. Proxy or polling fleets you have fleets to manage, and it's not particularly efficient and adds delays. Notifications make it simple and focus on how each application reacts. And second is speed. If you need processing to occur quickly when the new object arrives, on average notifications are sent within less than 1 second. And the third is integration, building blocks and new services to connect storage in S3 with workflows. The concept of event notification computing can architect applications in new ways where blocks of codes or workflows are invoked by changes in data. So it reduces the benefits of it is that it reduces operational complexity, no need to manage a fleet of EC2 instances, cost effective, you only pay for the number of executions on event handling code, and no need to fine-tune auto-scaling rules to limit idle CPU cycles. And it enables customers to solve some very challenging problems. So let's talk about cross-region replication. So this is a way for you to take the objects that are in one bucket and copy them to another bucket in another region. There are several use cases for this: compliance, lower latency, security. It's a way to also provide greater availability. If you were to have the same objects in 2 different regions, you could access them from multiple locations. So what this does, how it works is it replicates on new puts, and once configured, all new uploads from the source bucket will be replicated to the destination bucket. You can do this either on an entire bucket or a prefix basis, but it is important to understand that this is a one-to-one replication between any 2 regions. You cannot, for example, daisy chain these to go from one region to another to a third, but what you can do is you can say that you can have one bucket replicate to a bucket in another region, and then have that destination bucket then replicate back. This will not cause an infinite loop because each replication will only happen once. So this is a great way to have 2 buckets in different regions where you can put to both buckets and have the data appear in both buckets. It does require versioning, and deletes and lifecycle actions are not replicated, and this is really important. So what it allows, a couple things, is that one of the use cases for cross-region replication is to be able to have that recovery. So if someone were to delete objects in your source bucket, they would still be available in your destination bucket. We will only replicate the soft delete, which covers that up, but does not actually delete that object. It'll still be that version of that object will still exist. So for this region, you want to make sure that you have a good lifecycle policy on these buckets, because you do not want your non-current versions to continually build up. So to protect your costs, you want to make sure that you do have a lifecycle policy that will expire your non-current versions after some reasonable amount of time. So we talked about cross-region replication. automatic transition and expiration with lifecycle policies, trigger-based workflows with event notification, and easy recovery from accidental deletion with versioning. So let's move on to best practices to optimize S3 performance. So one of the challenges that customers have is when they want to transfer objects to S3, but they are on the other side of the world. What S3 transfer acceleration does is it takes the long-haul internet traffic, and we're going to accelerate that for you. You change your endpoint, not your code. Essentially what you do is you change your S3 endpoint to be S3-accelerate instead of just S3- instead of s3.aws.com. Instead of s3.amazonaws.com, it will be s3-accelerate.amazonaws.com. And that's all you have to change. There's no firewall changes, no client software. You just can put one checkbox in the console, change your endpoint, and you're done. And so here's other benefits. It's faster or it's free. That's right. If we can't do it faster than you can do it across the internet, then you don't pay for it at all. So how do we do this? Well, instead of going directly to your S3 bucket, you go to the AWS Edge location, and then we use WAN optimization over the Amazon network to bring that data to your S3 bucket. And we have seen for longer hauls from, say, Singapore to Virginia, we've seen increases of up to 80% in speed. It's been really crazy. And you can try it at s3speedtest.com. What this will do, will take your current computer and test it to all the different regions. You can see what the internet speed would have been and the speed with S3 transfer acceleration. This can be used, it's primarily used for puts, but it can be used for gets. If you have a smallish number of requests to remote regions, then this is a good option. If you have a lot of requests in remote regions, then you should probably be looking at CloudFront. Another optimization is using parallelized puts with multipart uploads. There are two main use cases for this. For in the general case, when we have a good network, we use it to aggregate throughput by parallelizing the puts on our high bandwidth networks. So we're moving the bottleneck to the network. You think about it, so if I had a 100 gig, if I had a 1 gig object, it would obviously take me less time to do a 10 meg object to upload that. So if I have 1,000 10 meg objects, 100 10 meg objects, then that would be, I could send those all in parallel, and while it won't be a 10x improvement, it will be a significant improvement. So the other reason that people use multi-part uploads is to increase resiliencies on networks that are error-prone, particularly mobile networks or remote or areas of the world where there is not good internet connectivity. It allows you to say if one particular part fails, then you can just resend that single part without having to send the whole object. So also faster download, you can parallelize gets as well. For large objects, you can use ranged gets and then align your ranges to get with your parts. So we would recommend that if you were doing a multi-part upload and you know your part size, say 10 meg, then if you use your gets with those same 10 meg ranges, then you'll be able to most efficiently retrieve those objects. And but for content distribution, you should probably use Amazon CloudFront. So as I said before, if you were having a lot of a small number of requests, then you should go directly through S3. But if you have a large number of gets that are coming in for a particular object, then you're going to get much more efficiency out of Amazon CloudFront to give that lower latency transfer to your end users. So I want to also talk about a new feature that we have. It's not actually an S3 feature. This is a new product called Amazon Athena. But what it does is it allows you to quickly access and query your data that's on S3. Kind of like Hive, serverless Hive. That's a good way to think about it. So it supports text, CSV, TVS, JSON, Avro, columnar formats such as Apache Orc and Apache Parquet. And it is accessed through the console or a JDBC driver. And it's $5 per terabyte scan from S3. So the best performance we have found for this and the cost is with the columnar format. And of course, if you are if you have compressed data, that will also reduce your cost. You are charged on a per query basis on the amount of the data scanned from the query. So compressed data will lower your cost. And I should also say that DDL queries or failed queries are not charged. If you cancel a query, we'll charge you for the amount that was scanned up to that point. As of this time, it is available in the North Virginia, Ohio, and Oregon regions. So let's see how you would get started with this. What you do is you log into the console, you create a table, and you create a Hive DDL statement. And you can use the console to add the table wizard. So there's a wizard that will actually walk you through all of this. Athena uses Hive DDL to define tables. When you create a table for Athena, you are essentially just creating the metadata, and as you run the query, the schema is applied to your data. Read-only query service on S3, your S3 data won't be changed by Athena. And we're only querying the data, we're not writing anything back to it. You can also get saved queries and then rerun them very easily. So every query that you run, it creates a history, and you can go back and rerun those queries very easily. So here's an example of a query that was done. The console will display the results right back to you. You can see exactly how long it took. In this case, this run took 17.34 seconds, and it scanned 12.97 gigabytes. For context, Athena uses Presto with full standard SQL support, and it can handle complex analysis, including large joins, window functions, and arrays. So now let's talk about the third topic we want to talk about is performance with high request rates. Now, if you are not doing a high request rate to S3, and by high request rate, I mean if you are doing less than 100 requests per second, then you do not need to be concerned about your key naming scheme. However, as you get to do higher and higher request rates, then you do want to pay attention to this. To be clear, S3 routinely scales up to millions of requests per second. But we need, in order to be able to do that for your bucket, we need to be able to create partitions so that we can scale out that load. The indexing layer is sorted in an alphanumeric order. So if you name your object starting with a date, all of these keys are going to be stored in the same partition. When you make hundreds or thousands of requests per second to these keys, you may see throttling and poor performance. So what you want to do is you want to maximize the distribution of your keys. You want to add randomness to the beginning of your keys with a hash or a reverse timestamp. You'll notice this starts with seconds so that we can distribute it well. But here's an example of a hash or some other type of randomness that is added to the front. And this will allow you to allow S3 to be able to partition your data so that you can get the highest throughput and get the best performance out of S3. Before I move on, I just want to point out that there are documents on the, well, this is a very important topic, and I want to make sure people understand that there are documents on the S3 website that talk about how you should be creating your key names if you are doing high TPS workloads. So another new feature from S3 is the S3 inventory. So we'll let S3 do all your lists for you. Instead of having to list out all your bucket to see what you have in your bucket, and we do have customers who have fleets that all they do is list their buckets because they have so many objects and it takes them so long. We now offer S3 inventory. You can save time. You get a CSV flat file output, and it's scheduled either daily or weekly, and it's delivered directly to your S3 bucket. And it's also very cheap. So it's half the price if you were to do the list API at 0.25 cents per million objects listed. Note that the destination bucket for inventory report has to be in the same region as the bucket that is listing. There is not a tag filter for this product, and report destination can be a different account, but the destination account needs to grant S3 put object permissions. So let's look at how we would configure this. Again, we're going to this management tab up at the top, and then we're going to the inventory. And you can select an inventory name, filters. You can filter by prefix, but you cannot do tags at this point, and the destination bucket. So you select a bucket from your account and a destination prefix, which is optional. You could actually have delivered to the very root of the bucket, and the frequency. And then you can look at the object version. So you could do either the current versions only, or you could do all the versions. And then there's some optional fields that can be included, including size, last date modified, storage class, e-tag, and replication status. I should note that this replication status is an important one to make sure if you are doing cross-region replication, you can use the S3 inventory to verify that all objects are in sync between your two buckets. And that's a great way to make sure that is true and there's no issues there. And you can do up to 1,000 lists per bucket. So it's really, really powerful. And you can also set up event notification to get a message or trigger a workflow when the inventory completes. So as I said, some of the best practices for performance: faster uploads over long distances with S3 Transfer Accelerator, faster uploads for large objects with S3 multipart upload, optimizing get performance with range gets and CloudFront, SQL queries on S3 for Athena, distributed key names for high TPS, a very important topic for me, and optimizing list with S3 inventory. So finally, we're going to go over some tools to help you manage your storage. So finally, we're to the tags section, as I've mentioned several times before. So these are tags that they're similar to the tags that you've used on other parts of AWS, where you can use for cost allocation, but these are slightly different because these are not for cost allocation. You can still do cost allocation tags on your buckets, but this is at the object level. And it's a way to classify your data. You can have up to 10 tags per object. You can tag with their key value pairs, just like the other kinds of tags that you have. And you can write policies based on the type of data. So you could say, if this particular, for access control, for example, we have two types. So access control, you could say that only if this tag exists would I allow access to these objects for this particular user. You can also do lifecycle policies, and we'll go into some of those a little bit. So lifecycle policies is interesting. You can say that this tag, for example, if you had two different types of customers, and you said that I'm saving their videos, but if you're in the gold standard, then maybe I'll keep your videos for longer than I would if you were a silver customer. So you could tag each of the objects that way and do lifecycle policies based on that. And you can put a tag to a new object. Either you can put it with a tag, or you can add a tag to an existing object. Because these are mutable tags. So this is actually the only type of metadata about S3 that is mutable. You can change the tags without re-putting the object. The maximum key length is 128 Unicode characters, and the maximum value length is 256 Unicode characters. Okay. So let's look at a access policy. This is a bucket policy where we say that we will allow a get object for this bucket when the string equals request object tag project equals X. So only if this is a project X object will this user be allowed access. So that's a really powerful way to separate out your permissions. And this can be, if you have a lot of users, this can be really, really powerful way to do this. So let's talk about auditing and monitoring events. So AWS CloudTrail now has S3 data events. Now we've had bucket events for a long time, but now we're adding S3 data events. And this allows, we have use cases for performing security analysis, auditing and compliance, and even to take immediate action on activity. You can set up, excuse me, you can set up CloudWatch alarms so that you can see on events that happen within your CloudTrail events, and that can be really powerful. So you can captures both the object level, captures the object level requests. It's enabled at the bucket level, so essentially everything in that bucket is not separated by prefix or tags, and the logs are delivered to your S3 bucket. The cost is 10 cents per 100,000 data events. So we still have the S3 server access logs, and you can continue to use those if those work for you. But this is a way to has slightly different data than in the access logs, in a different format primarily. So you can use this to understand your end user's behavior, tune access policies for tighter access control. So it can be very powerful for your use. As I said, you can actually monitor as well. We have new CloudWatch metrics, and these metrics are generated for data of your choice. So you can either do your buckets, prefixes, or tags, and up to 1,000 groups per bucket. So if you're running a web, mobile, or business application that depends on cloud storage, and you need individual visibility into the storage performance, so you can quickly identify and act on operational issues, then these CloudWatch metrics are going to be really valuable to you. This is something that customers have asked for a long time, and we're really happy to be able to provide these metrics. There will be 13 metrics, including request and bandwidth metrics, with a 1-minute granularity. And you can set CloudWatch alarms on these metrics. And this is 30 cents per metric per month. So it's a very reasonable cost to be able to get much more visibility into your S3 performance. So here's an example of, this is a data transfer. I'm sorry, this is the total request latency for a particular bucket. And you can see that this is around, so the point they've got listed there, it's 42 milliseconds is the total request latency for these at that particular point. And it goes up and down. And you can say that if the latency exceeded some value, maybe something a little higher than this, maybe at 60 or 80, you can also do that. Do be careful about setting alarms too low, though. You don't want to get into, you want to get too many alarms that you then don't act on. So make sure that they're actionable alarms. Here's all the CloudWatch metrics that we offer. You can see on the left, it's all the different requests that you actually make. All right, so do a count of request, put, get, list, delete, head, and post. And then on the other side, we have the bytes downloaded, bytes uploaded, and megabytes. The counts of errors, both 4xx and 5xx, as well as first byte latency and total request latency. So how do you configure that? Again, we're going to the management tab, and we'll hit metrics. And in this case, we will configure our example bucket, and we'll just add a new filter. So we can add a new filter there. And you can just add these two different types of metrics. So there will be 2 checkboxes for the 2 paid metrics. I should say the 2 groups of paid metrics. Each one of these is separated. There are 2 metrics that are free, which are your number of objects and the total bytes for your bucket. And these are all in the paid category. Here we manage your storage and classify. So we talked about classifying storage and managing access with S3 object tags, audit and monitoring access with CloudTrail, and monitoring operational performance and setting alarms with S3 CloudWatch metrics. So we've gone through all these, picking our storage class, automating our tasks, optimizing for S3 performance, and showing you some of our tools. So that's all that we have for this section, and we'll be going to the Q&A in just a moment.